Okay, now we start the clock on the real-time clock. We delay for a second, and then if that set time has been set to 1, that's what this means, then you go ahead and set the clock to the right time. Notice I had to manually put this in, and this is when I first did it. Eventually it'd be nice to be able to get that into the GROWSS app, or the Blink app, but I don't know if I can. But I've set it up so I have hooks here that if I can, then I can do it. Of course, it would not be in the setup loop. It would not be in the setup. It would be in the loop section, because that's what constantly runs. Okay, so we start the clock, we calibrate the clock, we print out some shit to see that the clock's working. This I pulled from the example. It's not that useful really, but it shows that it's doing something. Okay, then we start reading off the temperature from the BME 280. BME 280 get temperature. I got this from the seed BME 280 code here, which is not my code. But since they encapsulate the code and the header file, the C++ and header file together, it makes it very portable and modular. And that's what I modeled mine off of. So I'm going through and creating Fahrenheit here, and then I'm throwing a calibration on it. And this is a generic calibration that I took from my Raspberry Pi setup. It makes it close, but I haven't really calibrated. As I said, I haven't done the calibrations on any of these sensors yet. So, and then I'm reading out the humidity, and then I'm reading out the pressure, and then I read out the moisture sensors. Those are very basic. And then first time through, I set baseline high and low temperatures, humidities, baseline high and low values, so they're not 0, because you want to start somewhere and move from that. Okay, and then I do some serial printing. This is not under a debug yet, but I will switch it over to one of the debug flags so you don't see it all the time. But at first I didn't care if debug or not. I wanted to see this every time. Okay, so we've done all that. Simple. Now we get into the loop. It's run through that one time, and now we're falling into the loop where it's going to run over and over again. I get the time again, and then I take that time and I pass it to the hour, minute, second, year, month, day of month in the GROWSS time class, which was instantiated from this class, right? And here's all those values. The hardest part about this shit, when it comes to object-oriented programming, is knowing when to use dots and colons and how you access everything and pass those values around. For me, I found that was the hardest. So I get the time. Once again, there's no debug on this mode, no debug mode. I'm just printing it all out. So I print out all the time. I'll switch that over probably. Okay, and then we go back and we get the temperature one more time. Basically, we get it because we're going to go through this as a loop. So every time we go through the loop, we want to get the latest temperature, humidity, and all of that, and pressure. And then here's where I start going through my debugging and turning off the standard I/O. So basically, it gets the information, it passes those values to these local variables that I set up, and then they print them out through the serial. I get the moisture again. Once again, print out the moisture values. I delay 3 seconds. I let everything settle. And also so I can read shit without it flying by. Mostly, to be honest. I want to delay a little bit. I'm eventually going to delay 25 seconds or 30 between each reading. That's about all you really need. It's enough. Okay, now we're getting into functions. And this is going to be different for you if you've never seen it before. But basically what I'm doing is I'm using the method from the class to get a value and pass it back to the class sorry, let me try this again. I'm using the method in the class to pass the value from that method to a variable in the same class. So let's look at this, highs, lows, high lows. So let's go over here, high lows values CPP and high low values.h. Let's start with the header file. So you see this shit here and you're like, I don't know what that means. Well, basically it tells the compiler that only run this one time, don't try to run it over and over again, and only run it if it hasn't been defined already, or if it hasn't been run already. So you're not trying to redefine it. And this shit, I didn't know anything about it, but it fixes a lot of errors that you get from compiling that doesn't make sense. So put it in. Definitely put it in where you can. And I would recommend putting it into every header file. I didn't do it on this one. I don't believe. Did I do it on this one? I did not. I will be adding that to this one. I will actually listen to my own recommendations here. Okay, so now we have the class, high lows. And we have variables, high temp, low temp, humidities, high low, pressure, moistures. And then we have methods. First method is let's set the high value. Let's set this low value. And let's set the high moisture and the low moisture. The reason why I have to do these, high, low, and the moistures, because they're different returns right here. Now, for y'all, you guys and gals that are pros, yes, I can function overload, and I probably will do that in the future, but keep it simple. You start with simple and then work towards hard. Just getting classes and methods functioning by themselves was hard enough. Trust me. Trust me. So those are the classes. So we go back over here, and so we got high temp. There's the high temp. So we pass it in first. We pass the local variable gross temp that we read from the BME 280. And then we come into here, get to the top, set high value, which is right here. Set high value from high lows. And this is saying it's going to return a float. We're going to pass in a floating gross value, the gross value, which is a generic value because you can pass whatever value you want into it, and it just tells you, hey, it was either high or low. This is the modular aspect of it. If you said, hey, I want to pass the gross temp value, now you're stuck because now it's the temp value. You don't want to do that. You want to make these generic to understand. So you pass the high value, the gross temporary value, then what the high value would be, and then I set a local variable from within this. I compare the two. If high value is larger than gross value, then gross value becomes a high value. If not, then the high temp becomes a high value. If it's a high value, if it's higher than the current value, then we pass that current value as high value. Otherwise, it remains the same as it was before. And then return that high value. And this is the other thing that got me in trouble before, was trying to pass the class variables around. Do you pass it by reference? I tried passing by reference. None of that seemed to work very well for me. So I ended up looking at other code. Part of it's the BME 280, and some of it on the internet. And I realized that one of the ways that they do that is they create a local variable, so the scope remains in here, and they pass that local variable out. So you don't have any scope issues with trying to pass those variables around. I'm not going to go through every gory detail of this once again, because I know it's going to take fucking 6 hours. So here's the high value. You set that. Same thing. Now we're setting the low value. Same principle. Set the high moisture. It's the same principle, except I need to get an int out instead of a float. So we have to change that because it's an integer, not a float. Yes, I could overload. I'm not doing that. Okay, so you understand how that works. So now we go back. So we do all the highs and lows, highs and lows, highs and lows. And we can use the same functions because it doesn't care what values we pass in, as long as they're the right type, and it's fine. And then here's my enables, so I can print out the shit. I don't print all of it out, just enough to see what is going on. Eventually, I'll use the Blink app to do some more of the debugging once I get it working. But this is working pretty good. I haven't seemed to have any problems yet. Okay, now we check for alarms. Alarms. Once again, we're going to grab that temp variable out of the alarms. We go to check alarms, CPP and H. So here's the alarms, and here's our variables. Are the lights in, is the equipment on or off? Are there alarms? What's the moisture value? What are the thresholds to set each of those alarms? And the methods for checking both regular alarms and the moisture. Once again, I could probably function overload this, but I'm keeping them separate because they're two different. The classes output two different types. Sorry, the functions output two different types. So all that looks good. And now you go to the code. So we go to the top here. So we now have the alarms. We check it. We pass in a value. We pass the high in. We pass the low to see if that value is within a range. And
food's ready.
Okay. And we define, as we do before, we define a local variable to determine whether the alarm has been set or not. And then we go checking it. Equation here. Alarm is on. If all of this threshold and is all this, basically this equates to if the gross value is between the upper and lower threshold, then there is no alarm. Otherwise, the alarm goes on, and then we print some more shit out. I will be cleaning up some of the serial print shit, but I just wanted to get through this pretty quick. And this goes for check moisture. The only difference is now I'm using a switch case statement because instead of having a value come out, I'm having something come out that's text. Makes it easier to read than the numbers right here. So we do that. We check the alarms for temp. We check it for humidity. There is no pressure to check. Then we do the moisture stuff. And then here's the features shit for printing it out. The debug shit, I should say. Then we control the light. Now we're starting to do some controlling. So now these are done. Now we go to the control. You see how they're encapsulated together, and it makes it real easy. So we have the exhaust fan control. We have the light control. We have the humidifier control. And eventually I'll add dehumidifier and some other shit probably. So if I want to control the exhaust fan, I'm going to be using these variables, and then I'm going to use this method to do the controlling and then let me know through a bool variable whether it's on or not. So that's what this does. Is the light on? And we'll pass it. We pass the hour, which is the current hour. We pass when it's supposed to come on, when it's supposed to come off. We do that comparison, and if it's off, it passes a 0 to light is on. If it's on, it passes a 1, so we know it's on. There's my debugs. We set a temperature for this because if it's daytime, the temperature is different than it is at night. So we want to make sure that we adjust this exhaust fan based on whether it's day or night. We control the exhaust fan by what's the current temperature, what's the current humidity, what's the set point for the fan, what's the hysteresis for the fan, because I do go above and below it, so I have a range. I could also go a high and a low, but this works pretty good. Okay, and then humidity control, same kind of thing. You control humidifier, you pass the current humidity and all of the thresholds, and then we start in the blink LEDs. And this is the first step into the blink code that I've started with. And basically we're going to define what the blink LED colors are. So we'll go back over here, and guess what it's called? Set blink LED color. That's right. So, all the same shit. We have blink LEDs. And we have blink colors. Should be passed. Over. And then we define for every color what its ASCII color code is. And that's what the Blink app uses these to determine what the color is. That's a standard. And then these are these are basically constants, and these are the variables. Even though I don't have const string, but that's how they're being used. And these define the variables for all of the little widgets and LEDs on the Blink app that will be going there. So I'll have a Blink LED temperature. So on the meter when it's going in the Blink app, if it gets below or above, it'll turn to red. Let me know, oh, there's an alarm. Same goes for the humidity, density, moisture, same way. This tells me if the light's on. This tells me if the exhaust fan's on. This tells me if the humidifier's on. And then these are the methods that I use to set the blink alarm. And then I set the moisture alarm, and then I set the LEDs on whether they're on or off, which is the exhaust fan, light, and humidifier right now. So we go through that, then we set the blink alarm first for temp, then we do humidity, then there's no pressure to worry about. If there is, we'd be in so much trouble. And then we do the moisture for 1 and 2 moisture sensors, and then we do the exhaust fan stuff to see if they're on. And what's nice about this being modular, if I decide to add another moisture sensor right here, I just take this code, copy it, and then switch this to moisture 3. Obviously, I have to add it to my alarms class too, but it makes it really easy. And we know where the alarms class is because it's called, check alarm. It's in the check alarms class. It's in the check alarms header, and I should say. Anyway, so we've set them all, and then we come down and say, just for me to know that I've gone through the loop, that the NO's done, which is the loop's done. Then we wait about, 20 seconds, I think, something like that. And then we start the loop all over again. So that's the way it works, or that's the way what it looks like. Now let's see it in action real quick before I have to go eat. I was told that there is food available. So, word of caution when you use this IDE. It's a great IDE. I love it. The extensions, the coloring, the code. I mean, if this wasn't right, let's watch this. If I go like that, see how it changes the color? All of a sudden now you're like, oh shit, something's wrong with that. So it really helps for debugging, just generally looking at shit. One of the issues though is every time you launch this, you need to come down here and make sure that you have the right port set up and the right programmer, because every time you unplug the USB and plug it in, it switches to a different port. So you need to click on that and say, okay, which port do I need? I need the Arduino. And then over here you go click on it and say, which programmer do I need? And for this particular 2560, we use the MK2. And then what's your speed? Now I just left it 11.5200 because that's the default. So if you come up here, that's the nice thing, you can really bounce real quick around. In the setup, that's where I set it, what I set it to. Okay, let's upload it and look at some values. And let's see if I fucked anything up while we were working on it to see if it crashes or not. Not crashes, but doesn't get through the verification. And I have errors. Hey, I'm only human. It'll take a little bit of time here. Just keep watching the screen. I'm going to take a drink of my coffee. Takes a little time. It's prepping the board. It's verifying. If everything goes well, it'll start the upload. Good, it's uploading. I haven't fucked it up too much. And also during the upload, it will let you know, oh, here we go, serial port. Boom. Right on up. Ain't even slowing down, son. So this is the values. Okay, we're right here. So this is running through that code. You can see where this is. So up here, I come down here to here I say for time, went off too far. Here's the serial prints for that, which are right here. Right here. And then we go in the baseline high temps. So you can go through here, and this is the current time, and this is the current date running. And these are the values, 69, 58, 29. Pressure is exactly right. Temperature is not off by much. Humidity, I'm not so sure. I haven't had any way of really comparing it yet. And I certainly got to calibrate it. I don't have anything in the moisture values because my moisture sensors are in the air. And as you come down here farther, so what I did was I put in here, make it real readable where I'm at, moisture, what values they are, because this can be monotonous looking at this. So I implore you guys to put a little extra time to put a little bit more print lines in so you can see where you're at in the code. So I'm in the alarms function. So the value's 69 and the high value's 85 and the low's 54, and that's in between, so there is no alarm. Temperature alarm, so that, and now we have the values. Is the temperature alarm on? No. And then we check the alarms again because it's the same function. We're just cranking right through, and it's not. So you get the idea. Soil moisture, it's in 0, so it's air. That's where I showed you. Controlling the light. Is it between 9 and 9? It is, so the light's been turned on. Exhaust fan control. Temp is the same. We're at 90, so 90.5 or 89.5 is the range. We're at 58 for humidity, and its range is 80.5 to 79.5. And humidity, so 69.14 is below that, so the exhaust fan's not going to come on. And 58.15 is below that, so it's not going to force the exhaust fan on, so the exhaust fan is off. Humidity control. That's the humidity. That's the height, so 50.5 or 49.5. And humidifier is not on because it's higher than the highest, so we don't want it on. It's already high enough. And then the LED colors, which this is, it's hard to tell what it is, and I'm working on maybe adding something so we know. This is black, and I think these are green. And then we're done, and then we go right on through. Now, I'm going to wet my fingers and put them on one of the sensors. Get all the way down here. See how fast this shit goes? That's why I'm trying to slow it down. And let's see if it caught it already. Yep, see? Now it's perfect because I put my fingers on it. Now it's me. So we see it's working. So it's functional. It's in beta mode. There's more shit to do. But I have it at a state where I feel confident and comfortable. Both of those words, try to say those together, that I can hand it up to you guys, put it on GitHub, put it on SourceForge, and you guys can play with it and tell me what you think. Okay, this is Nighthawk as the Cannabis reviewer, I guess. I'm both Nighthawk and Cannabis reviewer. And I hope you like what you're watching. I hope this helps you out. Please subscribe and shit. Click my link. Go check my other website where I'm actually growing and have a grow log going on. And I'm in the summer 2020 grow, growing Granddaddy Black and Skittles glue right now. Check all that out. Please subscribe, like I said. Please like, post, comment. This is Nighthawk as a Cannabis reviewer. And as I always say, happy smoking.